Hello, my pre-calculus student. In this video, we are going to solve a system of linear equations using inverse of a 2 by 2 matrix. So let's review quick that before we can start to solve a system of linear equations. If we want to use inverse matrix, we have to make sure that matrix A is inversible. It means that we have to check for the determinant. Make sure our determinant have to be a number that's different than 0. So let's look at this system of linear equation. We have x plus 4y equal 3, 2x plus 9 equal 5. Of course, there are many possible way that you can solve this system of linear equation. You can solve by substitution, by elimination, by using matrices, or you can solve by graphing, but in this case we focus using the inverse of 2 by 2 matrix. So the first step we are going to do that we are going to write the linear system as the matrix equation matrix A times matrix X equal B. Then we are going to find the inverse and lastly we want to solve for matrix X. So let's start with A times X equal B. It will be the same as I'm writing the matrix A make up all of the coefficient of X and Y. So be 1, 4, 2, 9. X will be make up of the variable X and Y. So this is A times X equal B. B will be the constant, so it will be 3, 5. So next step, I need to find the A inverse. So to find the A inverse, we have to check for the determinant of A have to be different than 0. So start with matrix A. We have here the determinant of A is the differences of the product of your diagonal. So 1 times 9 minus 2 times 4. If you remember that we did this one in the previous video, I did this one more time, and that would be 9 minus A will be 1. So this is not 0, so we check. So therefore we can find the inverse right away. Now to find the inverse, we are going to start with when you write the augmented matrix. We put matrix A on one side, and then on the opposite side we put the identity. We have 1, 4, 2, 2, and 9. So the goal with that, we have to move the identity matrix to the left hand side of the line, and then on the right hand side, the leftover, that will be our inverse. So we do have a 1, which is good. So now we want to get a 0 in row 2, column 1. So what we are going to do with that, we will take -2 times row 1 plus row 2, that will be the new row 2. So that row 1 stays the same, so we'll copy row 1. So the new row 2 will be 0, 1, -2, and 1. Now next step, we do have 1 in row 2, column 2, but we need the number above this have to be 0. It means that the rest of the number in column 2 have to be 0. So we will take -4 times row 2 plus row 1, that will be the new row 1. So now we have 1, 0, 9, -4, 0, 1, -2, and 1. So from here we can see that our inverse matrix is the matrix on the right hand side, which is 9, -4, -2, and 1. So now we go back here. So we found our inverse matrix. Now we just have to solve for x, which is the matrix x. Therefore, our matrix x will be equal A inverse times B. Now we just have to substitute our A inverse and our B matrix. So our A inverse, we just found right here, 9, -4, -2, and 1. And our matrix B will be 3, 5. So now when you go ahead and multiply these two matrix, the dimension for matrix A inverse is 2 by 2. And for matrix B is 2 by 1. So the matrix X now becomes 2 by 1. So 2 row and 1 column. So I'll take row times column. So we have 9 times 3 plus -4 times 5. And then the next row will be -2 times 3 plus 1 times 5. And let's simplify this matrix. So 9 times 3 is 27, minus 20 should be 7. -6 plus 5 be -1. So therefore we can conclude that the solution to the linear system is the pair x, y, where x is 7 and y is -1. Thank you so much for watching this video. Please write your own summary. Goodbye.